The wave-actuated, tethered, emergency response buoyant reverse osmosis system is a desalination buoy founded out of the University of North Carolina at Charlotte by Dr. Landon Mackey and Dr. Wesley Williams, comprising of a team of undergraduate researchers, graduate students, high school scholars, and local business entities. Throughout the create stage, two small-scale pathfinding prototypes were developed. First, a prototype A was developed as a hydrodynamic stability and station-keeping pathfinder deployed in open ocean, and prototype B was expanded on those lessons learned and incorporated a small-scale power takeoff unit deployed in open ocean at Oak Island, North Carolina, and Jeanette's Pier. Following lessons learned from the small-scale prototypes, a full-scale prototype was developed in-house, fabricated at the Industrial Solutions Laboratory, and transported to the University of New Hampshire J.R.A. Chase Ocean Engineering Laboratory for wave tank testing. Wave tank testing allowed for simulation model validation against the Brett-Schneider wave spectrum and physical integrity, power takeoff, and station-keeping validation of the full-scale system, including fabrication methods and seaworthy readiness. Input from onboard sensors allowed the simulation model to be validated against the UNH wave tank spectrum, and agreement ranged between 77 and 92% of our predicted numerical values. Through a combination of analytical techniques and finite element analysis, system components have been selected and sized to ensure reliable performance during the competition, based on guidance from standards such as IEC 62600, DNV offshore standards, and Coast Guard deployment regulations. Initial fabrication was completed using as many off-the-shelf components as possible for a device capable of being manufactured anywhere in the world. During the power stroke, energy is transferred to the brine-assisted pumps to generate the required pressure for reverse osmosis, and during the recovery stroke, the tether is retracted and the assembly reset. Following factory assembly, the unit is loaded into the designated shipping crate and transported to the test location where it is connected to the defined lifting points. Final component assembly and adjustment occurs, and the unit is transported to the deployment site, anchored, and begins producing water. The create stage was used to refine the design, de-risk components, and perform extensive at-sea, wave tank, and laboratory testing to validate deployment and recovery methods, operational parameters, and to de-risk potential failure points. Throughout the drink stage, at-sea deployment and recovery will be refined. Pre-filtering systems will be augmented to ensure longevity of the reverse osmosis membranes, and optimization of the tether retraction mechanism and gearing ratio will be performed. The Water Bros team looks forward to having a drink at Jeanette's Pier in April of 2022, and continuing to advance wave-powered desalination for disaster relief and rural coastal communities.